So just to set a little bit of context about what we're going to discuss here today is around using open source to create a sustainable future. So if you look at the picture here, we're all here sharing the same planet, we're all sharing the same world. So this talk goes through some of the things we can do with open source to make a change, right? So it might just be a small change, so there might be one person here today can take something from this talk, take it back to your projects, but every little bit of a change helps, right? So just take some of the examples we're going through today. I work for Huawei. I work in the open source ecosystem development team. So part of my role is to actually work with many different open source communities. We're active here in the Eclipse Foundation. And some of the projects I will cover here today are Eclipse Foundation projects, and some of them are projects from other foundations. But we all have one thing in common, right? Because all of them are running as software on devices, taking energy, taking from our planet, right? So we're all sharing this planet together. So that's the context, and I hope you'll enjoy and stay with me for the half hour. So as I mentioned, we're trying to build, for a future where biodiversity and energy efficiency to make sure we all together have a sustainable future. So if you look at the world today, and from a tech industry, right? So we're here at an open source conference. So practically everyone here is from the technology industry, your developers, your testers, but from us together collectively, we also are facing the same crises that everyone else on this planet is facing today. So from a biodiversity crisis perspective, I was alarmed to see, I'm 46 years of age, right? So in my lifetime, I saw a report recently from the WWF. They were saying that it's 70%, in the last 50 years, 70% of monitored wildlife species have been lost, okay? So that's a staggering figure. And if you look at it from a freshwater perspective on our rivers, it's actually at 83%. I mean, I'm not talking about going back hundreds of years, this is just in my lifetime. And you look at it from an energy crisis, we've seen already, situations this summer. If you're from the UK, you'll remember there was outages in our data centers. So we're already seeing the effects of the crisis around us. And from a climate crisis, and I think this is very, very clear. I know myself, I had holidayed in West Germany in Trier before, and I was looking at images from, I think it was July 2021 when it was underwater. So it's actually heartbreaking, and that's just even in the locality around us, to see the effects of climate change, even here in West Germany, and devastation, loss of life. So again, I'm Irish, and even from an Irish perspective, we've seen our warmest summer on record. So we've had, a lot of visitors come to Ireland. We're not used to the heat. We're not built to the heat. If you ever see Irish in Spain, we're not built for it, right? So it is a crisis that we're all facing, and we're all facing together. But here together as a tech industry, we're going to be suffering even more as time goes on, because the resources on our planet are finite. We're actually having a reduction in our resources. And at the same time, our desire for data, our desire for intelligence, our desire to actually have all these services are growing. So we're actually seeing that by 2025, we're going to actually have a situation where we're actually increasing the amount of power that we want to actually consume and have in our data centers. So this is, an industry, as an industry, we're part of the problem, right? We are part of the problem, but we can also be collectively part of the solution, right? So this is what we're going to look at, some little examples that we can take where we are as part of the solution. And I'm here at an open source event, right? So you're saying, why open source, and why are we talking about this at an open source event? If you look at it from the technology that's used out there today, all the way around, everything has one fundamental thing in common. Practically every device that runs, whether it be in the cloud or out on your edge, or all the way out to devices, they're all built on open source. So we mightn't think of it, when we're actually doing our commits and our contributions, our software, think about how many devices are they actually running on. People that are utilizing our projects, these are all consuming from our planet. So if we can do things a little bit better. So I'm going to explore some things that we as a company in Huawei have been doing, and some of the open source projects that we've been working on, looking at it from taking you on a journey from projects that we're involved in from the cloud, projects to the edge, all the way out to the device, but also then looking at how we can apply them for our oceans, to our rivers, to the land. So basically, not only to actually make things more energy efficient and help reduce the decline in biodiversity, but also how we can actually use it today. And some hopefully might spawn some ideas in the projects that you're working on. So if we start with cloud, so, we at Huawei, we have Huawei Cloud. We actually, last week, we announced the first, launch of a Huawei Cloud that is going to come out of my country in Ireland. So we have Huawei Cloud here in Ireland. And as we say, we've actually worked across, we have a heterogeneous architecture that we work on, where we actually try to make the actual workloads, the chipsets that we run on, suited to different workloads and make them as energy efficient as possible. So it's not just the chipsets, you also have to have the software on top of these chipsets also optimized to make the energy efficiency that we really, really need to make sure that as we have the demand for more and more usage of our cloud services, that they're running as energy efficiently as possible. So if we start on the left-hand side, kind of for general compute, we have a project called OpenEuler. So OpenEuler is being highly optimized to run on ARM CPUs. So what we have noticed is that when we run and we optimize the software, we can actually get up to 50% energy efficiency increase from actually pairing the efficiency of the chipsets with the efficiency of the distribution. But it's not just in our workloads that we have in the cloud at the moment. If you look at it, everything that's happening in Europe, artificial intelligence is increasing. So more and more in the future, workloads are going to be AI workloads, from training data models all the way to inference. So we also need to make sure that AI is optimized as well, so that as we, as a society, start using AI more and more, we also make it as energy efficient as possible. So in this case, we work on a chipset range that we have in Huawei, which is called the Ascend chipset range, and we have a whole series of servers for the Atlas servers that run in our cloud. And we also have a framework, an open source framework, to really take advantage of the energy efficiencies you can run for running these highly optimized AI workloads on top of them. And then you have all these workloads, but again, you can also have poor utilization of your assets that are running in your data center. So the Volcano project is a project that runs at the CNCF, so the Cloud Native Foundation. And basically it takes advantage of actually scheduling to make sure that we have higher utilization of the resources that are running on these workloads, be it AI workloads, be it general compute. The more you can make them more energy efficient, the batch scheduling that it depends on can increase utilization by 60%. So again, all these measures can make the overall data center more efficient. But if we bring it more local to here at the Eclipse Foundation, you would say, okay, that's in the CNCF, but what can we do here in the Eclipse Foundation? This morning, a colleague of mine would have had a presentation, I'm not sure how many of you have seen it, about Open Services Cloud. It's a working group and a project that is launched here today at the Eclipse Foundation. And when I think about it from a energy efficiency, or how that might potentially have help in terms of our biodiversity decline, I look at it and I say, if you have a choice of where you run your workloads, so if you know that there's greener data centers out there, one of the things that's stopping you today is vendor lock-in. You might be using a specific managed service and it might be running on a data center and it's only run by one CSP. But if you have a choice, if we create an ecosystem where we have choice where we run our workloads, where we can actually create our managed service, it gives us a choice of where we actually run that workload. So part of Open Services Cloud is to make sure that there is no vendor lock-in, that anyone can create a managed service running on different CSPs. So you're given access to the fundamental abilities of the CSP to create a managed service. And now that you can have more and more of these managed services, the consumers that are using these services also then have greater choice about deciding where they actually run that workload. And when you give people a choice, and that choice actually has the benefits for the planet around us, it's a powerful tool. So again, it's something that's just launched here. If you want to get involved, this is just an initial architecture, so it's just at the kicking off point. So if you look at it, we have at the top level, you have your Open Services Cloud configuration language. So it's your OCL descriptors. And then we have the runtime. So basically, we're exposing, like a Terraform provider, a gateway to actually run on a runtime, such as Apache Graph Mino. But what it has is plugins to the various CSPs. So what you imagine down below here, CSP1, CSP2, CSP3. You can take this managed service, create a description of it, and actually run it. And per CSP, there will be plugins specific to that CSP to actually take the common descriptor and then change and actually deploy into the specific CSPs. So that's what will mainly happening at below the CSP orchestrator plugin and below. Again, as I said, this allows more and more of these Open Services Cloud managed services to start being there and actually being allowed more and more choice for the consumer about more and more CSPs that actually have this, where you're actually going to run your workloads. So this is something that, if anyone here is interested in, it's a project that's kicking off. My colleague down the back, JB, would be happy to describe. There's a birds of a feather tonight in this room. So if this is something that you feel strongly about, I advise you come along. There's free pizza. So hopefully you might come along. We go so we started on our cloud side, now we go to the edge. So there's another project that we've been involved in, which is called Cube Edge. It basically offers the ability to have Kubernetes native APIs, but geared for the edge. So taking just smart buildings as an example, if you take some of the efficiencies that you can get with AI, and I just mentioned already our Mindspore framework, and you combine it with intelligence of running your buildings efficiently, we have seen potential in smart buildings for 18% energy savings. But you think about all the buildings that are there in the world today. The more and more that you do that, each 18% is actually a massive saving when it's actually deployed across all buildings. So when you think about it we talk about smart buildings. When I think about edge, I think, I looked at the Edge Native and the IoT working group had an IoT and Edge survey recently. And this was done from the Eclipse Foundation. And they found that, big growth areas for the Edge are agricultural, automotive, it could be industrial IoT. All of these areas, when you take the same example that we had from a smart building perspective, if we start thinking about applying these energy efficiencies across all these different verticals, it has a powerful way of actually combining and actually working, in terms of massive energy efficiency across many. One of the key things with the Cube Edge, for example, as well, just so you know, is that it does have the ability to connect to the cloud, but it also has persistence so that if it loses connection, it can actually operate independently without connection. And now I take it down to device. So, when you think about it today, if you have your smart earphones, does it really need a connection? Does every single device that we actually put out in the market today, does it always need to be connected to the cloud? A lot of time, the answer is today they do. They connect to the cloud. And that's because the way they've been designed in, it could be from a monetization perspective, from a data perspective. But in reality, when devices are actually sitting very next to each other, close to each other, it should be built from the ground up to allow that in certain scenarios that you do not need to have these data connections. Because data connections to the cloud take energy. And if you think about it from IDC projections on the billions and billions of devices that we will have between 2021 and 2026, you could be the equivalent of, if every single device that is actually going to come on board is connecting, that alone could be 500 megawatt coal power plants running. So we have to think about, why are we doing that? Why are we making things that need their 2-3 centimeters apart to actually communicate through the cloud all the time? So here again, in the Eclipse Foundation, we have a project and a working group called Oniro. And what we've been designing from the bottom up is to make sure that as we build the operating system itself, we're giving the ability for the devices to communicate directly with each other. I'm not saying that they don't need a cloud connection, but that has to be optional. And this has to be the way we actually design our operating systems in future. And we build the tool sets on top of it and how we create our applications to have that flexibility, to have devices communicate together effectively. So what is the Oniro? So it's a distributed OS. So you might say, what are we targeting? We're targeting all sorts of devices, from very low resource devices that just can simply have an MCU inside them, all the way up to higher devices that can have gigabytes of memory. But what we want them to do is share this communication mechanism, that they all need to understand how to talk the same language. This is a very important very important feature, because that enables the communication to actually happen device to device, if each device is broadcasting its capabilities to actually one another. And what that actually enables is it enables the ability for what we like to consider, we call it like a super device, and it's the idea is that your devices operate around you. So you are in the center and your devices are operating around you. If they need to communicate to each other, they have the ability to talk to each other directly. And as I said, that has great aspects from not only an energy efficiency of not involving the data center when the data center is not necessary, but it also from a security point of view. And your personal data, if it's in your own house, it should be able to stay within your own, between your own devices to communicate together. But this needs to be designed from the bottom up, and that's what we're doing in the Oniro project. And if you've got interest in it, we have Oniro t-shirts as well, and we have Chiara here that's in the stand, and Donnie at the Oniro booth. And I welcome you all to come visit it and actually find out a little bit more about what we're doing with Oniro. But to dive a little bit, I'm just going to briefly go through this. Again, I better check my time that I do have time. There's a lot to our architecture. We put a lot of work together in the team in the last year. We're actually heading towards our first Oniro release, which will be hopefully before the end of November, which will be our first Eclipse release for Oniro. But we have a great team that have put a massive amount of effort to make sure that they have the tool chain to actually go along with not only the actual projects themselves. So when you're putting together an operating system that is as modular as we're designing, so we're using BitBake, the Octo project, to make sure that we use the recipes to allow this modularity, so that you have on the left side, you have your MCU-based devices, and on your right side, you have your CPU-based devices. But if you look, the most important thing is they all share the top layers. They all share, how they actually promote, how they actually interrupt as devices together as one super cohesive device. And the tool chain that we built around it works in basically taking that all the way from the image, making sure that all the packages that we pull in are actually open chain compliant, all the way out to running the devices in labs to make sure that they work together. So this is, again, I would invite anyone that doesn't know the project to come to our booth and check it out and find out more from the experts. And I'm going to give a plug for Stefan, who's in the audience today. I think you have a talk on Eddy project, which is the top layers that we're discussing there. So please check out Stefan's talk tomorrow. So we've looked at just a sample of projects from the cloud all the way out to the edge, and all the way out to the billions and billions of devices that are running around the world. But now we need to look at, okay, I'd like you all to maybe get an idea of what you can bring back to your projects, but also not just using the open source to run more efficiently. If we really want to talk about actual helping ease or slow the decline in our biodiversity, we have to start using technology as well to help maintain the biodiversity that we have on our planet. And that goes from all the way from our oceans to rivers to land. So I'm just going to go through some samples of ones that we have been involved with as Huawei with the technology that I was describing. So as I mentioned earlier on, and you'll probably get from my accent, I'm from Ireland. So this one is a bit of one that's close to my heart. And what you might see up in the top right-hand corner here is, for those that are familiar with the west coast of Cork, and I'm a Cork man, proud Cork man, this is Baltimore. So that's the pier in Baltimore. But what you see, and more importantly, is in the boat at the back of it is a buoy, and that buoy is blown up there. But what that buoy is a very important job. It's utilizing the power of our cloud AI system with the MindSpore in association with the edge, with the device on that's on our ocean, and it's listening. It's listening to the wildlife that is in our oceans around. One of the key things that people don't realize is that, one of the biggest dangers for whales is sound pollution. They depend on sonar. And the more and more traffic that we put in our oceans, the more and more it's confusing the whales and their ability for communicating with one another. So we've partnered with a group called Orca that are based out of Cork, and they're doing some research to see about how they actually can put in early warning systems for ships to say that in this particular area there's a high volume of whales, potentially lowering the sound pollution that is actually in that area at specific times. So this is just one example of using technology to actually try and help, maintain the populations and hopefully recover some of the populations of our whale life in the oceans around us. And again, I start with oceans. Let's move into rivers. Okay, so when we look at it from in Norway, I'm going to just highlight the first little video that you see here. It's identifying salmon. Okay, so this is just doing basic AI to identify, different species of salmon. Why is that important? Because of us humans, back in the 1950s in the Russian White Sea, we introduced, they're kind of like a horrible looking fish, but they're an invasive species. That's the humpback salmon or pink salmon that you see at the top of the screen. And what happened is, because we as humans introduced them, they managed to make their way down along the Norwegian coast. They then went up the rivers and spawned in ones that have been there for many, many times, for many, many years. It's wild Atlantic salmon used the Norwegian rivers. But because we introduced the problem, these pink salmon took over as an invasive species. They were able to reproduce faster, so what's happened was they caused a massive decline in the stocks of the native Atlantic salmon, threatening them. Actually, if it's not reversed, if the trend's not reversed, they could be potentially become not the actual natural fish of Norway. So one of the things that we got involved with was getting in what the device you just see down below here is a device that actually uses not only AI to actually find out, well, what species of salmon are going up the Elva rivers, but also take action. And you see the gate that's flipping forward, back and forth here. This gate is allowing the natural salmon to go to the top feeding grounds or the top spawning grounds in Norway to allow the Atlantic salmon to regain. And again, it's using technology that I mentioned, like MindSpore, for example, to create the types of AI models that are needed to actually make the actions happen in real time. So I'm not saying that your projects all have to do exactly the same thing. I'm just hoping that it will spawn some ideas of how it can actually help. So we've gone from oceans, we've gone to the rivers, but we're also looking at inland. And I'll take an example from Italy. So in Italy, we're working very, very closely with the WWF, which the gentleman that you see up there has a very important job. He is to actually look after all these, they call them the areas called the oasis. So some of them is in Naples. It's like the crater of Astroni. I probably won't pronounce it right for the Italians, but the crater of Astroni. And other areas such as around Grosseto. And what the problem that they have is that even though these areas are protected, they're actually not protected enough because they don't have enough rangers to cover the land. So what you see there is a device that's called a Guardian, and that Guardian is solar powered. It's placed at the top of the canopies so that it actually can, the power itself is basically from the sun. But what it can do is it can keep an ear out, okay? So one of the things about humans is that we're noisy. If we're actually taking out a gun, the gun makes a bit of noise. If you're actually chopping down a tree and you shouldn't chop down a tree, it's actually chainsaws make noise. If you're actually doing off-road biking in an area that you shouldn't be, you're making noise as well. So this is tied then in real time to give the rangers the ability to respond. So this is a massive tool. It's just a simple idea, but it's a massive tool to help cover a wider range to make sure that we're keeping the biodiversity in these areas in Italy. I know I'm kind of conscious of my time, but I'm going to get time for questions, but I'd like to see if there's some time for questions. But I'll step a little bit back out just from pure open source. Huawei as a company has also made commitments across all its products and services. We call it Tech for a Better Planet. And that's not just putting goals on ourselves as a company. We're also putting goals on all our suppliers, our top 100 suppliers, also to go to more renewable energies, to basically reduce our carbon emissions. But as I said, I know we're here at EclipseCon and it's an open source event. We really want to focus on how we can actually, do the work with you, the communities in open source. And it's just a selection of the projects that we're involved in across many different, all the top major open source foundations, from the Apache Foundation to the Linux Foundation to the Eclipse Foundation. And even as I just mentioned here in the Eclipse Foundation, you'll see the Open Services Cloud and the Oniro projects that we're highly involved in here locally in the community with you, the Eclipse Foundation community. So I'm hoping that, I've taken you on a journey. There was a bit of a whirlwind to cover cloud, to cover edge, cover devices, cover how to actually, utilize them and examples to give. But there's more because we actually have a booth. I'd love you to come and talk to us at the booth, and visit us. We have T-shirts, Oniro T-shirts. I'm wearing one, so modeling it here. So please come and collect your T-shirts. We'd love you to come and talk to us. But I think I just have about enough time for Q&A. And if anyone has any questions, I'm happy to try and answer. Everyone's shy. I hope, okay, if there's no questions, I'll leave you finish up, but I just hope that you might take back, even if you don't join the projects I just mentioned, like Open Services Cloud and Oniro, that you take some of the examples and bring it back to your own project, even if it spawns a little idea of something that you can use your technology that you have in your project to do something, then every little helps. So hopefully that half an hour spawns at least one of you to have one thing that might change. It all counts, all right? So thanks very much.